Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have 3 to the power of x is equals to x, and we solve this problem for all the values of x. So here first we find all the roots of this equation, and at the last we will be verify that which of the roots are solution and which of the roots are extraneous root. So now we move toward the solution of this problem, and here first we will take natural log on both of the sides. So when we apply this log, we obtain log of 3 to the power of x is equals to log of x. So here we use the nice property of log, and you know about that. If we have log of a to the power of m, this is equals to m times of log a. So according to this property, or this property just tells us that if you have exponent inside the log term, we just move this exponent in the front of this log, and according to this rule, we move the exponent x in the front of this log, and this will becomes x times of log 3 is equals to log of x. And now in the next step, we move the variable terms to the right hand side, or we move the constant term to the left hand side. So here we have just this is x. So in order to move this to the right hand side, we divide both of the sides by x. So here you remember that our x is an non-zero value. So that's why it is possible to divide on both of the sides by x. This x and this x are gone, and we get here log 3 is equals to, this is log of x divides x. And here we just use another exponential property. So according to this property, you know that if we have any number a, and if we apply log and anti-log at the same time of this a, so this will be written as e to the power of log a. So according to this property, we just write this x as e to the power of log x. Okay, so according to this exponential property, we replace this x is equals to e to the power of log x, and it will be written as log x divided by e to the power of log x. So here we use another property. You know about that. If we have 1 over a to the power of m, so we write it as a to the power of minus m. So it means that if we have exponential term in the denominator, when we move it into the numerator side, then we change its sign. So you see that this is e to the power of log x. When we move it to the numerator side, we write it as e to the power of minus log x. And in the left hand side, we have log 3. So here we use the nice Lambert W function, and I hope so you already know about the Lambert W function, but now here I can little bit explain this. So the Lambert W function states as if you have w of a times e to the power of a, so the output of this type of function is equals to a. It means that if you have the exponent of e is multiplied by here, then the output of this function is equals to the exponent of e. So according to this property, you see that the exponent of e is minus log x, but here we have positive log x. First we need to make the exponent is multiplied by here. So for this, we multiplying both of the sides by minus 1 on each of these values. So when we multiply it by minus 1, we get minus log 3 is equals to minus log x times e to the power of minus log x. So now we are ready to apply the Lambert W function to the above equation. So here we apply this w on both of the sides, and we get w of minus log 3 is equals to w of minus log x times e to the power of minus log x. So here, when we use the Lambert W function, the definition of Lambert W function here, we just get the output of this function with the exponent of e. So we obtain here, this is minus log x. So w of minus log 3 is equals to minus log x. So here first we move minus 1 here in order to get the value of x. We multiplying both of the sides by minus 1. So we get, this is minus w of minus log 3 is equals to log of x. So here for the values of x, we need to remove the log into the right hand side, and for this we take the natural log, we take the anti-log on both of the sides, and this will becomes e to the power of minus w times minus log 3 is equals to e to the power of log x. So here we write the left hand side as we move this term to the denominator side by applying this nice rule. So according to that, we write it as 1 divides e to the power of w of minus log 3 is equals to, this e and this log are gone and we get here x only. So further in the next step, you see here we get, this is the only one value of x. But if you can use here the Wolfram alpha function, and this value of this term gives us the complex root. Okay, so this terms gives the complex root, and this solution is called the complex solution, and here we cannot get the real solution, or this equation has no real solution. So this is our final answer, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.